very much looking forward to welcoming the Christ College New Zealand Aerospace Challenge finalists 2019 to come forward and present to the council. And congratulations on being finalists. I'm really excited about what I heard on the day of the finals, and I'm inviting you to share that with our councillors, but also this is being live streamed, so it's an opportunity for you to be sharing this with the City of Christchurch, so welcome.
We are a group of young, aspiring Christ College students who have entered the New Zealand Aerospace Challenge Finals for 2019 with the goal of creating a sustainable solution for an agricultural problem using satellite and drone technologies. In order to achieve our goal, we have created 2 products, the first being measuring river flow rates throughout Christchurch, throughout Canterbury, using satellites, and the second being teaching with satellites, in which we can help students learn the science using a real-world application.
The imagery we used were obtained from the Sentinel-2 mission, which is a constellation of twin satellites of the Sentinel-2A satellite and the Sentinel-2B satellite. And so these 2 satellites are operated by the European Space Agency and were manufactured by Airbus Defence and Space. They have a multispectral imaging capability where they use 13 parts of the light spectrum, visual, near-infrared, and shortwave infrared. And based on this, we were able to use it to measure river flow rates. So this is a satellite image of the Waimakariri River, which is the local river, and the area selected in yellow was the area of interest that we used to analyze. So this is a close-up image of the area of interest. We happen to have a shingle quarry nearby, and on this we use the formula on the bottom right, which is green rays minus near-infrared rays over green rays plus near-infrared rays. And why we're interested in that is because water reflects green rays and absorbs near-infrared rays. And so with this, we were able to make a histogram, as shown on the bottom right. And because water reflects green rays and absorbs near-infrared rays, we were able to isolate it from vegetation and shingle. And then we counted the water pixels to isolate it from vegetation and shingle. And so this is another day with clear water flow. So as you can see, the water is very dark and the color of it is similar to the surrounding trees. But still, as I said earlier, water reflects green rays and absorbs near-infrared rays, so we were still able to count the water pixels and isolate it from everything else. This is another day with a high flow event. This time the color of the water is similar to the shingle, but again, we were able to make a histogram, count the water pixels, and isolate it from everything else.
Right. So we were able to use these images to look at the surface area of the river and the volume as it flows down, and we were able to use that to project river flow rates and compare them to the measurements taken by ECAN along our river. Now, the red dotted line you can see on the screen is our model based on the amount of shingle we believe to be in the river, and we're able to get that quite accurate in that as during different days as the volume rises up, we could see the red line would shift, and we found that useful to know because the thing is the entire Canterbury Plains have been built on shingle that's been moved down through the rivers, and if shingle is going to be rising up too much, we end up with flood risk events and things. We were also able to use the river flow volume data to colour code the Waimakariri to look at different amounts of flow going through, and we can look at as the volume decreases, we know that water must therefore be dropping off and disappearing into the underground aquifers, which means that we were able to look at the amount or just going in there to work out things, because the aquifers are used for irrigation and for the Christchurch water supply, which we also found is something that we should be looking at and want to know more about.
Okay, so as you can see, that graph over there is we can actually compare from the satellite flow rates, what the satellite gets, to ECAN, and so the ECAN measures at an old highway bridge, and as you can see, our data is almost exactly the same as the ECAN data, and that really certified to us that this could be a viable method of actually analysing the flow. And so there's also going to be another second satellite which will actually increase the frequency of results by 5 times, so we can get results 5 times as much than ECAN and other sources. So so we decided to take our project a bit further with the radar, and so we set up these corner reflectors right here, and we set them up in Hagley Park so that a satellite could overpass us and it would actually send out a radar image to the satellite.
The radar works through sending a pulse out, and these corner reflectors are set up so they're 90 degrees, and so they directly reflect them back to the satellite, and through this we're able to have a larger reading, and it makes the instrument see and have a much larger dots.
Yeah, so it basically gives a really distinct red dot, and that's, as you can see on the left, that's a radar image, and we actually set up the corner reflectors in the shape of the Southern Cross, and the first one right there is the easternmost star, and the one in the distance is this one right here, and we've actually decided to make some Christmas cards, so Merry Christmas from Christ College to us and to you, and we'd like to give these to you, and if you want you could buy them for $10, and all the proceeds will go to the Christchurch City Mission. So cool. Thank you.
Okay. No. You've got to answer questions now. Sit down. No, so because the reason that one of the things that I was particularly inspired by when I met you on the day was that this experiment or this project that you'd been involved in actually led to the school looking at its whole curriculum and the way that students were able to be engaged in their own learning in a very special way. So would you like to comment on that at all?
So basically this project was like a culmination of a lot of efforts by the teachers and Dr. Taylor especially. So basically, for example, in level 1 they're doing internals, in level 2 we're using the data for statistics internals and things like that, so it can actually be implemented into the curriculum. And right here we're sort of a product of it itself. We're presenting our ideas about it, so yeah, I think it's a really good idea.
Yeah. So
Could I just say?
yes, please.
Our year 13, the project started as a year 13 Earth and Space Science project, and those students did a level 3 internal at the beginning of term 2, and then we got a little bit more scientific than just counting pixels that looked like water, and developed it. A year 13 stats class used it as a time series analysis internal for term 3, and then the boys here are mostly year 10s because all of our seniors, aside from James, are all on exam leave, and they have done it as part of the economics projects and business development projects associated with the Ministry of Awesome, which they also attend. We also managed to sneak it into our Duke of Edinburgh expeditions to the Lewis Pass, where they take a stick and they measure flow rates on the Boyle and Lewis rivers, so we can calibrate data in the high country as well. So that's probably the main teaching coverage from the teacher's view.
Yeah,
You've had the student view.
It is fantastic, and I mean, actually, that was incredibly helpful to have that, because I mean, what we're hearing is that the sort of from the teaching point of view, but also from the learning point of view, and it really gelled with me. So I'm so pleased that we've had the opportunity for you to come here. Do any of the councillors have questions? Tim?
This was presented at an electoral debate early on in the season. I have to say, although I thought I spoke really well, it was by far the most interesting thing of the night. But I do want to thank the teacher, because to inspire young people to want to achieve and go forward is a really special thing. And although I kind of didn't do too well at school, I do remember those outstanding teachers. So thank you for what you do.
Yeah, and I think that given that these Christmas cards, which are absolutely glorious, by the way, that a stack of them sell for $10, so I'll be expecting all councillors to put their hand up, and we'll send the money directly to the City Mission if that would be good for you, because I see that all proceeds go to the City Mission, so we'll take care of that. We're not taking a freebie from you. We're going to add value to your mission. So thank you very much for coming. Much appreciated.